Hi, in this video I'm going to talk about action potential propagation. This is the movement of an action potential along a membrane. So I'm going to draw up an axon and we're going to have a look at this axon at 3 different points in time. So this is the same axon at these 3 different points in time. So let's get oriented. This is the axon and this is the nucleus in the body of the neuron. And this segment here is called the axon hillock. The axon hillock is where action potentials begin. So a stimulus is applied to the axon hillock, and usually this stimulus is what we call a graded potential. We're not going to talk about graded potentials in this tutorial, but just know that they are a flow of positive charge. Now everywhere but the axon hillock, the membrane is at its resting membrane potential. The positive stimulus of the graded potential is enough to trigger an action potential in the axon hillock. And as we've seen in the last video, this means that there is a transient reversal of the charges across the membrane. Now what this means is that there is some positive charge from the axon hillock that flows into the next segment of the axon. This is enough to trigger the action potential in the next part of the axon. Meanwhile, the axon hillock returns to its resting membrane potential. So here's the charge flowing across here, and this positive charge flows into the next segment of the axon. This is known as local current flow. Now I'm sure you can guess what happens here. There is an action potential triggered in the next segment of this axon, and meanwhile, the previous segments have returned to their resting membrane potential. The local current flow then moves into the next segment of the axon and triggers an action potential in that segment. And this process continues until the action potential has propagated all the way down the axon. So the last issue is to address why doesn't the local current flow backwards and trigger an action potential in the other direction? The answer is that it does flow backwards, but it doesn't trigger an action potential. The reason for this is in the molecular biology. The voltage-gated channels that are in the previous segments are in what we call a refractory period. This means that they can't be activated again. So we'll have a look at the channels again and see why this is. Remember that when the channels close, they don't actually close by flipping the gate shut. They close by this ball and chain mechanism. When the ball is in the channel is totally inactive and can't be triggered again. After some time, the channels will reset entirely, and then they will be ready for another action potential. So this is an overview of how action potentials propagate down a membrane. This membrane doesn't have to be an axon. It could be the membrane of a cardiac or a muscle cell. Now you should have a pretty good understanding of how action potentials work and the molecular biology behind them. For more free tutorials and the PDF for this tutorial, visit www.handwrittentutorials.com.